So our last couple of examples, we did condensing down, so the ones that look complicated but are actually very simple. We did the expanding out, the ones that look simple but are complicated. And now we're going to do some verify, just like we did in the last two sections. So I want to verify that the cosine of 3 pi over 2 plus x is equal to the sine of x. So I'm going to start just by drawing that line down the center. I'm going to work with the left-hand side, the side with the sum. It's a lot easier to work with that than it is to work with a nice simple sine x. You gotta get pretty creative if you want to turn sine x into something. So cosine of 3 pi over 2 plus x. Cosine of a plus b is what I'm going to work with. So I'm going to work with this cosine a plus b, expand this out. So this expression is cosine 3 pi over 2 cosine x minus sine 3 pi over 2 sine x. Okay, now we have two things with actual angle values. 3 pi over 2 is 270. So here's my 3 pi over 2 column. So cosine 3 pi over 2 is 0. So now we have 0 times the cosine of x. Sine 3 pi over 2 is negative 1. And so this piece turns to 0, this turns to positive sine x, which is what I wanted it to be. So we're done. Pretty simple compared to some of the verify questions you did previously. This last example is a little bit different. It says sine of theta is 1/3 and theta is in between pi over 2 and pi. So that means theta is in quadrant 2. Cosine alpha, that little A kind of looks like a fish, that's alpha, is 2/5. And alpha is in between 3 pi over 2 and 2 pi. So that means alpha is in the 4th quadrant. So we want to find the exact value of sine theta plus alpha. So the first thing I'm going to start doing is I'm going to expand out sine theta plus alpha, and I'm going to use this top formula. So sine theta cosine alpha plus cosine theta sine alpha. That's what we're working with. Now I'm going to plug in some values for these trig ratios. I know from right here that the sine of theta is 1/3. I know from right here that the cosine of alpha is 2/5. Now, to find the cosine of theta and the sine of alpha, we got to go back a couple of chapters here. So I'm going to draw myself a picture. If I know that theta is in the 2nd quadrant, here's theta. This is its reference angle. I know that the sine is the opposite over the hypotenuse, or the y value over r. And so I can find the third side of that triangle, just Pythagorean theorem, 1 squared plus x squared equals 9. And then that would be the square root of 8. So I know from that picture that the cosine of theta must be negative 2 root 2, because this is a negative direction, over 3. So where I have cosine theta right here, I know it has to be negative 2 root 2 over 3. I'm going to do the same thing for alpha. Alpha's in the 4th quadrant. I'm going to draw my reference triangle. Here's alpha. Here's its reference angle. I know cosine is the adjacent side over the hypotenuse. And so if I do 4 plus y squared equals 25, I get negative square root 21. Negative because of the direction, not because of the Pythagorean theorem at all. Which means sine alpha is negative root 21 over 5. So sine alpha, I can put negative radical 21 over 5. So I'm able to use the exact values from my triangles to help come up with an exact value for this sum. Now if I clean this up, I get 2/15 plus a positive 2 radical 42 over 15, which means sine theta plus alpha must equal 2 plus 2 root 42 over 15. For letter B, we're doing the same idea, only we're using tangent. So I'm going to start by expanding tan theta plus alpha. So that's the second to last one. It's going to be a tan theta plus tan alpha all over 1 minus tan theta tan alpha. Almost drew a theta there. So now if I go up here, tan theta, I'm going to move my picture down. Tan theta is opposite over adjacent, which is 1 over negative 2 root 2, plus tan of alpha is opposite radical 21 over adjacent 2, all over 1 minus 1 over negative 2 root 2 times negative 21 over 2. So I'm going to clean up just a little bit. Let's start just by putting together our bottom denominator. This is still going to be minus, it's going to be root 21 over 4 root 2. Now I'm going to multiply by a common denominator. Tangent, it's all about the simplifying that usually gets to be tricky in these questions. So if I multiply everything by 4 root 2, that should clear out my denominators. Oops, sorry about that. Okay, so what we end up with is a negative 2 minus radical 42 all over, up 2 radical 42, all over 4 root 2 minus root 21. Last thing we need to do is multiply by the conjugate to help us simplify. Rationalize is what we're simplifying at that point. 4 radical 2 plus radical 21. 4 radical 2 plus radical 21. And we get negative 8 radical 2. Let's see, minus 2 root 21. Minus 8 root 84. Minus, well, 2 times, it's going to be 42 root 2 if you simplify that. So root 21 and root 42, they each have a 21 in them, so that's going to come out, which is where my 42 came from, 2 times 21, root 2. And I got 16 times 2 plus 4 root 42 minus 4 root 42 minus 21. All right, so let's clean up a little bit. Negative 8 root 21 minus 2 root 21. 84 has a 4 in it, so it's going to be minus 16 root, if I take a 4 out of there, 21, minus 42 root 2. On the bottom, that's 32 minus 21. So let's see, negative 50 root 2 minus 18 root 21 all over 11. It's a beautiful tangent value right there.